Sir, shall we start the session?
Yes, sir. Yes.
Yes, sir. Okay. Thank you. Good evening, everyone. Today, Atal 6 Days Faculty Development Program. The title of Next Generation Green Energy Powered Electrical Vehicle and Renewable Energy Integrations Using Solar Microgrids. Now we are entering to the session 13. The topic is Challenges and Opportunities in Floating Solar Photovoltaic Technology. Today's session chair, Dr. P.V.V. Ramarao, Professor, Department of EEE, MVSR Engineering College, Hyderabad. I will read about the biopic profile about the Professor P.V.V. Ramarao Garu. Sir completed the BTech in JNTUH, Hyderabad. After the MTech, also MTech in Electrical Power Engineering in JNTU College of Engineering, Hyderabad. PhD completed in JNTU, Hyderabad. Sir having 25 years of academics experience in various positions like lecturer, assistant professor, associate professor to the professor, head of the department in EEE, dean in R&D, finally principal. Sir organized a lot of, apart from the things, NBA coordinator, NAC coordinator, Board of Studies member, Academic Council member, Governing Body member, etc. Achievements. Sir published around 46 international journal. Also participated in 39 international conference. Sir attended the workshop around 42 numbers. Also conducted 31 numbers. Not only workshop, FTPs, conference, etc. Sir guiding the PSC scholar, 4 students under Sir guidance now doing. Apart from the four candidates, 1 already PhD scholar awarded. Sir attended 26 number of the national conference. Also, Sir gave a lot of experts lectures around 52 numbers. Not only that one, Sir served as a judge as well as a chair, almost 21 different events. Sir having the professional body membership like LMI, SITE, FIE, member of IUCWE, member of WASET, member World Scientist, Engineering Academy and Society, member International Association of Engineers, and member International Society for Development and Sustainability, SMIEEE, like that. Apart from that, Sir now serving as a editor-in-chief, iManagers Journal in Circuit and Systems. Also, currently Sir serving as a reviewer, some few international journals, also conference. Sir acted as a session chair, almost seven international conference. Sir organized 3 national conference. Also, the Institute of Engineers in Andhra Pradesh State Center Electrical Division member elected for 2017 to 19. Sir received Emerging Leader in Engineering Award from Venus International Foundation in January 2019. Sir received Best Academician from Society for Learning Technology, Hyderabad. Also, Sir applied funded projects. Sir got completed also ongoing some projects. I will recap. Hello, audible? Hello, sir. Also, sir got applied a lot of funding agencies like SERB, AICT, APSSDC, MSME like that. In terms of 76 lakhs, 27 lakhs, sir completed the funded projects. Also, 100 lakhs is ongoing. Sir also filed 4 patents. In that one, 3 patent published. Currently, sir working as a professor in EEE, MESR Engineering College in Hyderabad. Welcome, sir. Welcome to the session. I'm hand over to the Dr. Ramarao, sir.
Yeah, thank you, sir.
Thank you very much, sir. Please.
Thank you, sir, Ganeshanji. So I think I have rights to share my PPT. Have you given my this one rights?
Yes, sir.
Yeah.
Public only, sir. You can, sir.
So, is it visible now?
Yes, professor. Visible.
Yeah, first slide, the title slide.
Yes, professor.
Yeah.
Make it full screen.
Yeah. Full page. Full page already just now, of course.
1 minute.
1 minute. So now I am making slideshow. So is it now delivering?
No, professor. Waiting for response.
No.
Yes, professor.
No, I reduced it just a minute. Otherwise.
And down. Yeah, down. That one you can use, please.
Now okay.
Not.
Changing or not?
On F5, sir, to big screen.
Hey, here I am doing it, but whether it is there coming there or not, I am doing all sorts.
Okay, professor. Anyway, you will try.
Just a minute. Otherwise, yeah. I'll share again.
Okay, professor.
But I'll do PDF. I'll share it. I'll make it full view. Is it sharing now? I'll make it full view so that.
Yes, professor.
Yeah. So how it is. Is it okay?
Okay, professor.
I think it is not changing properly. Just no.
Not changing.
Not changing.
Mm.
The second slide is moving. Changing.
No, sir.
No.
No. Now you are in first slide.
No.
No, sir.
Oh. That is not changing.
Now only moving. Now you are in third slide.
No. Okay. Right. But full,
Okay, sir, you
full
carry
slides,
on.
is it coming or not?
Now currently you are in third slide.
The full slide is coming. Full
No,
view.
no. No, no.
It is not coming.
Yeah, full view not coming.
Now. Here I am trying everywhere.
Okay, professor, you carry on.
That's okay, right?
It's not changing. No issues. You carry on.
Yeah, I don't know why it is not changing.
Sometimes like that only.
Yeah. Otherwise, I have to rejoin. But anyway, it's time wasting because
Yes, professor. Please.
Hello. Yes.
Mm.
Yeah. So thank you very much, sir, organizing committee and Siva Ganeshan sir and Saravanan sir for introducing me. the participants. I don't know. I think most of the participants I might be knowing, or they might be knowing me directly or indirectly. So coming to the challenges, directly I'll go to the topic, because already we wasted almost 10-15 minutes time. So challenges and opportunities in floating solar photovoltaic systems. In short, we usually call it as FSPV or sometimes FPV, like that. Okay, in literature, you'll find this keyword FSPV or FPV. That is stands for floating solar photovoltaic systems. Even when I came to when I was invited to deliver a talk on challenges and opportunities, till then I never, of course, what you call reviewed or what you call done some studies on challenges and opportunities. But here, I don't know. There are still many challenges to be solved or to be overcome to bring in the full or complete features of floating solar into existence or into the real time. And before going to see the floating solar power plants or power systems, photovoltaic systems, FSPV, one should understand why you have to go for the solar or wind or renewable energy. Now, this is what Niti Aayog, I don't know how many of you are going through that, MTOE, that is million tons of energy.
একটা ভাব চারিদিকে।
Am I audible? Somebody please respond. Am I audible?
Yes, Professor.
খুশি খুশি দেখাচ্ছে।
That is what actually here, okay, so the energy demand is increasing. And this is the Niti Aayog report. You know, already the government of India is aiming at 2047, that is Vikasit Bharat 2047. That is like Vision 2047. Because 100 years we are going to celebrate the the Jubilee, like Platinum Jubilee, something like that, 2047. So here, that is what actually the thing is increasing. Energy demand is increasing, and on the other side, the fossil fuels are what you call degrading, or of course their effects, bad effects, are environment. Pollution is increasing day by day. Energy demand is increasing, and the pollution is increasing. And of course, let me take this opportunity, all of you. Today is Energy Conservation Day. I don't know how many of you celebrated this National Energy Conservation Day in our country. It is 14th December and National Energy Conservation Week, 14th December to 20th. Somebody please respond. Anybody has celebrated in our colleges or organizations? Anybody? We celebrated. Hello? Anybody? Professors? Beloved participants? They are allowed to talk, sir? Participants or not? They are allowed to talk?
Yes, sir. Yes, sir. We made public, sir. They can.
Okay, right.
Yes,
so I think kindly share entire screen. Yeah, I am sharing, but I don't know whether they are doing it or not. I am full screen. Actually, it is made full screen, but I don't know why it is not changing. Anybody like celebrate? Yeah, that's what actually. Let me take this opportunity to extend the what you call the celebration day. Okay, welcome. That is National Energy Conservation Day. And I strongly feel that energy exists everywhere. I think most of you agree with me. Energy exists everywhere. It's like that even in our day-to-day life, we use a lot of energy and we gain a lot of energy. Use and gain. That's what both sides it will happen. And if it is positive environment, and we will gain more and more energy, and if it is negative environment, that means sometimes our day may not be good, and sometimes our day may be very good. Sometimes it all depends on how we are acting or reacting for different tasks. That's what so energy exists everywhere, and on the other side, energy excites everyone or everything. Do you agree with me? Anybody at least chart yes or no? You can type, no problem, right? Just is only an interactive session. Okay, hope you also know that something about floating solar power plants. And solar photovoltaic systems, and myself. Yes. So Paniseva Gopal Ram City. Thank you. Yeah. That's what actually here the things are revolving around energy nowadays, and we people mostly depend on electrical energy nowadays. But here, of course, the what you call the PPT is sharing about Niti Aayog report and different types of what you call sectors. Actually, what we can say that sectors: building sector, industry sector, transport sector, agriculture sector, like that, miscellaneous and all. So how the demand is increasing year by year or day by day, one can understand by the time 2047, the forecast is saying that almost 2100 or 2200 million tons of energy is required. It is an equivalent figure actually, million tons or megatons of electrical energy. And whereas on the other side, the energy supply by 2047, like solar, wind, hydro, nuclear, different forms of energy, right? Coal or oil and petroleum products, natural gas. See that how they are also changing day by day. It's also million tons of energy and import dependence, gas import dependence, oil import dependence, cooking coal. You can get it actually this in Niti Aayog website. There is a beautiful report about energy vertical. There are different verticals in Niti Aayog: agriculture vertical, energy vertical, health vertical. Like the different verticals are there, and for each vertical you can find the report and the projections for 2047. That is Vikasit Bharat 2047 with an objective of make in India or digital India or startup India, to meet or to achieve everything to be manufactured in India, everything to be developed in India, and entrepreneurship India, like that. So you are finding, and these are all energy emissions intensity to your domestic growth. That is what actually gross domestic. That's what GDP, what we call it as GDP. And this is what kg CO2e per 1,800 rupees. That's the energy emissions intensity. Energy emissions intensity also just we have to see that it should be reduced by 2047 to almost half, something like that. We can say that 2020 to 18 or 20 around, and 2047 within 25 years, it should be like half of the. So that is what actually about the energy requirements, energy supply, and then emissions per GDP. That's what So all these things are provided. That is why you have to meet that objective of energy demand by by the time 2047 arrives, or Viksit Bharat 2047. We should reduce the dependence, especially oil dependence, coal dependence, because they're all conventional sources, energy sources, and those are not what you call renewable energy sources. That is why we should, and that too environment is damaging. So pollution, environment pollution, that is CO2 and all, right? It is increasing. So that is why we have to reduce. Of course, I am not talking about the advantage, disadvantage of all those things. Let's straightly go to solar photovoltaic installations. And these are all actually different forms of solar photovoltaic installations. You can see that floating is one among the solar PV installations. And apart from floating, you will find canal top, rooftop, and we are all just very much or pretty much aware of the rooftop solar photovoltaic installations. And nowadays we are seeing that even canal top, ground mount, and offshore solar PV installations also. So that's what canal top means, over the canal. That's what we are can see that. And coming to the these are all and a small diagram. It is shown here. That's what actually. Just give me a minute. Give me a minute. Just you are seeing the diagram. That's what, are you seeing the photovoltaic installations? Okay,
Sixth slide, sir.
basic,
Now
yeah, a basic diagram.
yes, sir. Sixth
Yeah,
slide.
one can go through that sixth slide. So key influence factors on solar PV, one can go through that. What is key influencing factors? And we all know that, right? What is the influence? The major factor or main factor is like sun irradiation, what we can say that. Here it is shown that emblems or symbols, okay, the images. So these are the key influencing factors or influential factors behind the energy yield, okay, using solar or solar PV or from the solar PV plants, okay, solar PV. In general, one can understand that. See, if you are, why I am telling in a specific manner these key influential factors, one can focus, okay, research on source side, or other can focus on converter, and another can focus on time, okay, area, like that. So your focus, depending on the influential factors, you can select one or two or all these influential factors, and you can do research and you can publish papers. There are so many areas. Again, in source, right? In source side, right? You can go through that, how to capture that source irradiation, how to capture, how to utilize maximum irradiation. There may be different methods. Okay, different methods, different types of solar. What you call is not solar cell. There are no different types of solar cells, but module, okay, formations, maybe arrays and all, okay, solar arrays, right, like that, or mounting, right, different types of mountings. That is what actually can may avail, okay, much of the solar energy or irradiation and convert. That means much of the means much extent you can convert the sun radiation, irradiation to our electrical energy. That's what actually here one can think of these key influential factors, okay? And converter design and time, right? So what you call time of utilization, or okay, time of interconnections, okay, time of connections, like that. And then area, okay, depending on area, geographical location and all. And coming to the why you have to go for floating solar photovoltaic systems out of the 5 different forms of solar PV installations, like rooftop, canal top, okay, offshore, okay, road mount, okay, like that. When you have other types of, and of course, well documented procedures are available for rooftop and canal top, whereas still there are some challenges and opportunities in this floating solar photovoltaic system. That's what, okay, maybe it is like okay, an emerging technology or innovative technology, like directly on water, sited directly on water, no mountings and all. So mountings may be reduced, that is, hard structures may be reduced, but still some structure is required, okay, to make the modules float on the water or on the surface of the water. But anyway, there is some kind of innovative technology that modules or solar PV panels are sited directly on water. Then first of its kind floating is done by a trial by research agencies in Europe and the US, with installations of a few kilowatts. Of course, anything will start with okay, very few, or okay, less than 1 or something like that. And of course, when it comes to the idea of floating solar photovoltaics, it is very simple idea: array or combined array or module of panels, right? PV panels placed on floating structures. That's what I told you. Structure is required, but hard-mounted structures are that much big size of structures may not be required for this. But floating structures that keep the panels float on the, are sited on the directly on the water is required. And now this National Renewable Energy Laboratory, US actually, you know that, and it is suggesting that, or suggests that this floating solar PV can generate around 10% of the US annual electricity production. I checked that India, but I didn't get any reports or even in literature also. So how much it can generate, okay, the annual electricity out of annual electricity, deploying all these solar PV panels on the reservoirs or canals, etc., floating. But this is what you can understand. See, US announcers that are suggesting that 10% of the US annual electricity production can be done by solar photovoltaic. Means in our country there is much and more scope. Around 25% or 30% now you can go for solar floating solar. So these are all actually what you call. So please go through that. Of course, one can understand. So what are the advantages, or what are the requirements, or what are the challenges? Maybe right in single slide, one can understand. Okay, what are the factors? Okay, driving us to go for installation of floating solar power, solar photovoltaic, and see all this. Okay, compatible with electric infrastructures, water available for cleaning, electrical safety of equipment, no land preparation required, no land acquisitions are not required, because land acquisition means is a big task, and so many statutory bodies to be involved, and public what you call occupation may be disturbed. All those things are there. Reduced algae growth because of solar intensity and all, right? You know that solar intensity, light intensity, will reduce the algae growth, which is contaminating the water contamination. And reduced light reduction may have environmental impact. Reduced water evaporation, maintenance may require diving. Okay, like that. So these are all different. Cautious. See, caution symbol is there, tick mark is there. See that, okay? These all those things, right? One can go through that. And this is what one of the world's biggest inland floating solar system in Singapore. Okay, it is there in one of the publication. Yes, and you can see that in the website also, reneweconomy.com.au, one of the world biggest inland floating solar system. I have not taken entire diagram and different diagrams. Just to inform you. Actually, this construction has started, I think, in 2020 or 19. I don't know, it is over. These are all large-scale photo, what you call floating solar PV installations, photovoltaic installations, world level. I didn't see even India also. Just I think India started, Andhra Pradesh 25 megawatt in Andhra Pradesh, but Telangana I think is not there so far. West Kallada, India West Kallada 50 megawatt NHPC, and this is BHEL. So BHEL. And actually, nowadays, this NHPC, NTPC, all these conventional, what you call organizations, conventional power plant based organizations, or power corporation, maybe we have to say that, National Thermal Power Corporation, National Hydro Power Corporation, all these corporations have started combining and doing some ventures with SECI, that is Solar Energy Society of Corporation of India, that is also SECI, or we call it SSC. Solar Energy Corporation of India. So all these corporations are coming together and installing what you call providing infrastructure. That's what developing the infrastructure. This solar PV wind installation they are doing. Even recently, I've seen that NTPC Green Energy. Even they entered into stock market, and NTPC Green Energy. They have started green energy related projects like that BHEL, like that NHPC. Okay, and these are all different installations at the world level. See that 70 megawatt, 60 megawatt, 58.5 megawatt. 47, 25, 4. Out of this, I think the largest is 60 megawatt single. This is actually 2 into 35, Vietnam. 60 megawatt, and then followed by Thailand by 58.5 megawatt. And ours is 25 and 50 megawatt, West Kallada. I don't know where it is situated. Okay, West Kallada. Hope you are all going through that. Is it okay? Fine. Presentation is going smoothly, or any problems? Is it changing my slides and all? Though it is not full, slide not moving. Somebody just now, slide not moving. Sir, slide not changing. Then I'll reshare. Just I'll stop and reshare. Okay, sir, changing. Somebody, yes. Okay. Just now I got it. Anyway, I'll try to. Is it presenting PV floating plants outline? Yeah, you are saying that share entire screen instead of sharing a window. But I'm not getting it actually. When I tried that, anyway, I'll try again. Because he is saying that entire. I'll try entire screen. Okay, entire screen. What it is coming now? Yeah. Okay. Now, is it somebody please respond? Is it showing PV floating plants?
Yes, sir.
Yes, sir. Yes, sir.
Okay, right. Okay, full size. Okay.
Full size coming, sir. Yeah.
Yeah. Yes. Thank you.
Yes, sir. Thank you.
Yes. This is what actually outline. One can get it. What is okay, floating PV, solar PV, that is FSPV, and here okay. So the modules, solar modules, of course, PV panels and PV modules. Okay, and most of you confused about panels and modules. Okay, panels little bit different. Panels is only series parallel connections of our solar cells. Then series parallel connection of panels is our module. Mostly that parallel connection because it will increase the power and the same voltage like that. Panels are connected in parallel so that they will get increased power and the same voltage like that. That's what panels. And then coming to the floaters, weight also to maintain that floating properly, that is just on the surface of the water or sited on the water. Then underwater cables you'll have and substation distribution lines also. Anchor also plays a role in solar PV floating plants. One by one we'll see, and then once after understanding the construction and all, right, operation, of course, no need to explain any operation. Usually modules will convert the radiation into electrical energy, and electrical energy will be distributed through or collected through our cables, and then pumped to substation, transmitted to substation, then later load centers through distribution centers and all. Right, that's what. So here, please go through that because some of you might be knowing that basic components, but still clearly go through the what are the important components. Okay, floats, anchoring, mooring and anchoring, modules anyway, but balance of system components. Okay, these three are somewhat important. Okay, when you talk about floating solar PV plant, the structure, when it comes to the structure, the basic structure consists of floats, mooring, and modules. These three are the basic components. Anyway, modules you can take it out because it is solar PV. So that, but when you want to make it floating, solar modules or PV modules as floating. So floats or pontoons are required. Floats are also called as pontoons. And then the mooring and anchoring, that's what is like bed type. Okay, mooring lines are anchoring is bed type, and bed type on the bed you'll have the floats, and then floats will carry the your PV panels or PV modules. Okay, on the floats PV panels will be there, PV modules will be there, then connections and all, of course, later, and inverter, converters, etc., transmission line later it comes. Okay, but these are the three important things. Okay, balance of system components, floats, mooring and anchoring. That's what is it moving now? Okay, different FSPV plant structures, small size, pontoons with metal structures, then PV modules placed horizontally on thick elastic mat. Like that, these are the three different structures, floating solar PV plant structures. Small size PV, A, figure A. And figure B shows that pontoons with metallic structures, okay, holding rows of rigid PV modules. And third one, placed horizontally on thick, okay, an elastic mat. Thick elastic mat, okay, C, that is shown. And these are all, okay, maybe with the simple flowchart, one can understand the important components, okay. Anyway, photovoltaic module and inverters, solar energy system, any system, that is any type of installation, okay, rooftop or canal top or whatever it is, okay, they require cable and connections. These two are most important, and balancing of system component is also important. Last two, right? Last two are very much important. Okay, these are the different, okay, different structures required, structural components required for particularly floating solar PV system, right? And here commercially available three types of structures employed for FSP plants and PV module support frame made by FRP, and unit structure stainless steel, and floating system, this is one, and second one, and third one. It looks like, okay, the diagrams are also shown, right? Looks like. And this is what HTP, okay, non-slipping surface, that is HTP material, okay, that's high density, okay, polyethylene, something like that. Okay. And what is floats? Okay, floats are pontoons. So, except for the floats, which bring the necessity of mooring and anchoring, the rest of FSP plant is almost the same as ground-based installation. That's what I told you. Except the floats or pontoons, these floats and pontoons require again the necessity of mooring and anchoring. That is why, except floats, okay, which also bring the necessity of mooring and anchoring system, the rest is same as other types of PV installations. So, what are the floats then? So, these are nothing but some compartments with buoyancy to keep PV modules and supporting structures float on water. That's all. So, floats usually recyclable, non-toxic, resilient to water, salt corrosion, because at least they have to ensure, we have to ensure the radiation that can ensure more than 20 years of operation. That's why usually recyclable and non-toxic, resilient to water, salt corrosion is one. And three main floats is pure floats with high density. That's what I told you, polyethylene, HDPE material. The second one, hollow cubes, that is pontoons, they are also called as, with metal trusses. And third one is special membranes or mats. Okay, that's what all three types it is shown already. Then next comes to the major part, that is which are required by the floats. Actually, floats need or bring necessity of this mooring and anchoring for floating solar PV. So mooring refers to any permanent structure. So usually there are three common types of anchoring for floating PV plants. And anchoring on piles, shown in figure A. Bank anchoring, that is shown in figure B, is like, see, our boats or ships float on the, okay, the water, right or not, surface of the water. But when it comes to the shore, near to shore, how you will anchor the boat to stand there, okay, like that. Support, it is a support system, anchoring on piles. Then bank anchoring and bottom anchoring. There are three types, okay. The first one is anchoring on piles, then second one is bank anchoring, and third one is bottom anchoring, right? That's what. So usually the anchoring will prevent the plant from being blown or pushed away by wind load or wave force and or water streams, or hit the banks when the water level is changing. That's what boats will take care of. How will take care of boats, ships, etc. against wind loads or wind forces or wave forces or water streams, okay, to safeguard that boat or ship, right? Like that, even floating solar PV installation should be made, the sufficient arrangement or adequate arrangement is to be made. That's right. Now coming to the actual, okay, our topic. I think I have taken 25-30 minutes, okay, introducing. So far I introduced the, okay, what is floating solar PV plant. Hope some of you are, most of you might be knowing, but I also learned, right? So many things, right, for this lecture. There are several features, of course, and functionalities associated with this, what you call this type of system, which might bring both opportunities and challenges. Okay, so I'm going to, this is actually purely from a reference paper. I'll share that reference paper also, and this will help much for the research scholars can work, those who are looking for some topic, maybe they can think of. You can, I think you can simulate also some of the things in this floating solar PV systems. Like, see, you can design your floating structures using AutoCAD or specialized CAD softwares. Okay, and you can prove that, okay, our structure is okay, long or durable or something like that. You can prove, or efficient, or okay, reliable, like that, stability, reliability, and all. You can prove it, okay, through your structures design, and of course on the other side, or voltage profile, etc. Anyway, harmonic components and all, inverter, converter configuration. All those things are there on the other side, pure electrical engineering. When it comes to floating, maybe floating structures also you can include. Maybe even you can plan for a topic that is our research topic towards the structure influence, okay, on the production generation of the solar energy. Okay, the how far this structure influences, or the wave forces, etc. influence, or anchoring or mooring, okay, different materials, combinations, etc. But anyway, what are the opportunities? I told you already in one of the slide it is shown, okay, no land preparation, land requirements, land what call gathering, pooling of land or something like that. Land pooling. Usually we say that land pooling, because we are using water area, that the existing reservoirs, etc. That is a non-revenue generating surface. It's a non-revenue, right? Keeps the land saved for other land incentive markets such as housing, agriculture, tourism, mining, etc. This is a trivial fact supported by literature, but I don't know okay, how far it is realistic. Okay? A real-time opportunity, but it is a trivial fact. Okay, supported by literature. And radiation balance. Okay, so what do you mean by radiation balance? Usually, the PV modules absorb as much as the radiation, and they have very low albedo. Therefore, land-based PV plants strongly modify the land albedo, which depends on the type of material. Okay, covering it. Okay, and the example vegetation is 20 to 30%, but desert it is 40 to 50%. Such a radiation imbalance, actually, the radiation imbalance may raise issues related to that particular location, right, where your plant is okay, located or situated. Okay, that's what we can say, that local temperature and microclimate, okay, may cause radiation imbalance. Okay, or radiation imbalance may raise issues related to local temperature, vice versa, right? Microclimate. So for the water, however, albedo is only just around 6%. Around 6%. So here I'll take a minute, just okay, to tell you about okay, what is albedo. Anybody? What is albedo? Of course, we can search, of course. It is the fraction of, like, power factor. See, we say that power factor, okay, how much of active power is being utilized out of apparent power or reactive power. What is the ratio between active power and apparent power, right? So out of how much power is being utilized, like that. So fraction of sunlight that is diffusely reflected by a body. That's what albedo. And see that how much variation. Okay, the albedo. Okay, if you go for land-based PV plants, and if you go for water-based PV plant, that is floating PV modules. Therefore, okay, the which goes with the low albedo of the PV modules, and therefore no to low radiation imbalance will happen in what we call this okay, floating solar power photovoltaic systems. Then increased efficiency is another opportunity. Increased efficiency, floating photovoltaic system, edgy one, large footprint and smart grid. Okay, to medium footprint, freestanding, then rooftop. You can understand. Okay, freestanding and medium, right? So heat loss coefficient is given as a FPV system versus heat loss coefficient. Large footprint, medium footprint, freestanding. So see, freestanding, what heat loss coefficient, right? You are having. So here the convection is the main cooling mechanism for PV modules. So in air, above water area is cooled down by the air. So that is why, air above water area is cooled down by the air. Therefore, PV modules which have negative temperature coefficient work at higher voltage, which leads to more efficiency, total energy yield. Study is showing that in tropical climates, example Singapore, irradiance weighted temperature difference, floating PV can reach up to 14.5 degrees. While for maritime climates like Netherlands and all, this value reduces to 3.2 degrees Celsius. That is what actually heat loss coefficient compared to reference rooftop PV in Singapore. This is the graph actually. Okay, so that is the convection, right? Main cooling mechanism for PV modules. Air above water area is cooled down by the air. Okay, that's what. Therefore, PV modules have negative temperature coefficient. And so if we have which have a negative temperature coefficient work at higher voltage, which leads to more efficiency and total energy yield. Okay, more and more energy yield, right? If they work at low temperature or negative temperature coefficient. And of course, water evaporation, right? So see that here, water evaporation is some. You can check the water evaporation also. Okay, floating PV, then data logger, ultrasonic, water temperature sensors, weather station and all. Right? When deployed this sweet water reservoir, okay, floating PV can reduce the rate of water evaporation. You know already, water evaporation usually takes place, and when PV is in between the water and radiation or light falling, definitely evaporation will be reduced, right? Because it is not that much subjected to the environment, right? Moisture and all, right? Such as Morocco, in some countries such as Morocco, water evaporation can reach up to 3 meter cube per meter square per year. Right? See that. A study performed in Jordan showed that installing floating PV can reduce water evaporation by 60%. See that. So these are the experiments conducted in Jordan. And synergy with hydropower plants, okay. And you know, right, the power production curve of hydropower plants is mainly governed by water cycle or water season, okay, which complementary to sunlight irradiation cycle. Therefore, hydropower plants and floating solar power plants can work complementary. When this is working, you can switch off or take it off, take off, okay, off that one, like that, okay, benefiting each other, right? You can have good structure, benefiting from the surface of the calm water behind the dam and the already established. So like that, okay. So complementary work, right, can be produced, okay, greater energy efficiency or greater energy or throughout the year, throughout this season. Okay, what you call apart from the type of season, that means independent of water seasonal cycle, you can make it out. So a research studied 20 largest hydropower plants across the world and concluded that by covering 10% of the HPP basin surface, the HPP's energy production is increased by 65%. So figure shows hybrid HPP, FPV. Maybe it is like hybrid HPP, FPV. So this is also one. See, nowadays actually people are publishing the papers on hybrid energy systems. Okay, solar PV, wind. But wind also people are not, because it is not across the globe. Winds are not different, solars are not different. That is why, according to your region, your location, particular location, you can conduct several studies and publish the paper, right? Research studies and publish the papers. Hybridization. So hybrid HPP and FPV, right? That is also one good area. Actually, I think I have seen not so many papers, but still there is a scope to get published the papers in that area. Okay, so and there is another opportunity. Of course, it is everybody knows that. Okay, cleaning. Okay, effective cleaning, easy and effective PV module cleaning, and of course on floating also you'll find dust and dirt. Okay, but see, cleaning maybe because water is available, so that then and there itself, right, we can make it maybe less expensive. What we can say that effective PV module cleaning and less expensive PV module cleaning can be done. Okay, and as frequently as possible also it can be done compared to land-based PV systems. Land-based PV systems usually they are at rooftop, something like that, or okay, the dust formation is very high, dirt formation is very high, and you have to carry the water or something else, okay, to clean the modules. This figure shows a snapshot of robot cleaning for a floating PV system installed in Spain. Okay, Spain. It is there in the paper itself. So opportunities still continues. Improved water quality. So any questions here? Otherwise, I'll take last. Okay, at the end. Maybe another 15-10 minutes. I can make it. Right. So improved water quality. That's what actually evaporation is reduced. Okay, reduced evaporation. Almost see how much figures are showing that 60% evaporation is study performed in Jordan showed that 60% evaporation. Oh, very good. Improved water quality. See that improved water quality. Okay, so there is lower chance of algae. That's what I told you. It is shown in the one of the picture also previously. Okay, so because see light penetration into water is less because of the floating. Because PV modules are sited on the direct on surface of the water. So that is why light penetration into water will be reducing. So thereby lower chance for algae growth and therefore higher water quality is expected. And see the total nitrogen for water quality assessment, usually total nitrogen, total phosphorus, chloro, a measure of total photoplankton abundance, CHLA, and cyanobacterial chlorophyll, a measure of potentially toxic cyanobacterial abundance. All these things are usually measured, right? So the results showed, research results are showing that no discernible impacts on water quality as a result of PV installation, or even improvement reported by observation of limiting this cyanobacterial abundance, right, and nitrate concentrations. 1/3 to half coverage is recommended by the literature to preserve water quality while reducing water evaporation. That is also one, but it is only literature, okay, evidence. There is no real-time or practical evidence. Okay, and longer lifetime. So land-based PV plants placed in dry areas benefit from high radiance, but modules experience more severe thermal cycles as a result of high day and night temperature difference. Just a minute. Just a minute. In 1 minute, just a minute.
Okay, Professor, take your time.
Is it sharing now?
Yes, sir. Visible, sir. Screen.
Full screen? Yeah. Yes. Okay. That's what longer lifetime anyway, because when they are subjected to thermal cycle and that to different temperatures, the morning to evening, night, there is a large difference actually, more difference in high day and night temperatures. So that's why day and night temperature difference is high. Usually, that is why it influences the lifetime of the modules. That's why longer lifetime we can have. Okay, and because thermal cycle will be somewhat restricted by the water. This one because it is floating on the water, so that the thermal difference can be reduced. That's what temperature difference is reduced a little bit. That's what it is observed. So when PV modules are deployed on water across 24 hours, they experience very low temperature difference. So because the water has high heat capacity, so that is what actually it is making higher, longer life. Lifetime is increases, and ease of deployment. This is what last opportunity. Ease of deployment. Even land based PV also easy to deploy. About type 1 and type 2, that is two of the floats, deployment of floating PV system can be easy and quick. Leading float manufacturers reported that when supply chain is in place, a team of trained installers can deploy between 500 to 1 megawatt per day. This is okay working how they are installing. Usually 500 kilowatt to 1 megawatt within a day they are installing. Trained installers, and if supply chain is available, okay, in place, supply chain is in place. Okay, that's even same thing. I don't know why it is reported as, of course, opportunity, because on the other side, this opportunity is also there in land-based PV installations. If supply chain is in place and trained installers are there, easily they will install 500 megawatt and all in a day, a single day. Then so anchoring, this is the challenge. Okay, it's a complex mooring and anchoring. That's what usually we observe when we make journeys through ships and boats and all. I don't know how many of you traveled in ships and boats. I traveled several times, and anchoring and mooring, the system choice and design might change per morphology of the installation location. And the factors, influencing factors, are type of the soil at the bottom of the water place, water depth, maximum water level variation, also size, size of the plant, photovoltaic system. And depending on the size and number of PV modules floating are sited on the water, the number of mooring lines, depends. That's what number of mooring lines you have to place, and size is increasing, then mooring lines increases. Around 30 mooring lines are needed per megawatt photovoltaic. This subscript P, I think most of you know that. What it stands for, I think some of you know that, or most of you know that. Subscript P. In literature and all, you will find. Anybody? You can message on the chat box. Anybody? What is subscript P? Anybody? Please think of. Or you can search it. So photovoltaic, actually solar. Okay. Even sometimes photovoltaic, we don't write PV. So that is solar. One can understand that it is a solar generation, like that one can understand. So usually about 30 mooring lines per megawatt solar plant, floating plant. And figure shows Anhui CEC-based floating solar plant, China, 70 megawatt, which uses bottom anchoring with 1500 anchors. This is one of the China floating. And dirt and biofouling accumulation and hotspots. Okay, this dirt and biofouling accumulations. Although soiling is most server for PV plants in dry regions with the dust events, but research is showing that dirt and biofouling is a considerable effect for floating PV systems. Birds visit floating PV systems quite often. If not cleaned, dirt and biofouling cause hot spots and damage PV modules. This is what actually here in the diagram, here you can see that the figure shows heavy biofouling on PV modules and reflectors and hot spot as a result of that. So this is another challenge, right? You have to identify and you have to see that, okay, it should not be formed. Biofouling and that should not be formed considerable considerable amount. So that, okay. So modules with higher tilt are less likely to get fouled by birds, as it is more difficult for bird to stand for a long time on more tilting modules. And another two challenges: difficult maintenance, impact on water ecosystem. Though it reduces light penetration into the water, that is why evaporation and all, but underwater biomass and photosynthesis rate it reduces. So it is the point of note, point to be noted. So floating PV might reduce oxygen concentration or O2 levels, which can affect fishes. Low oxygen concentration can also increase methane release in shallow lakes. So that's what the research reported. Anoxia is more frequent under floating PV plants compared to open water areas. Okay, that's what anoxia means. Low oxygen concentration is called anoxia. Is another point, impact on water ecosystem. Though there are advantages of floating PV in terms of maintenance, such as easier access to water for cleaning and lower risk of theft or vandalism. But generally, maintenance procedure is preventive, corrective, or what you call maintenance. Okay, for floating PV plants is not as straightforward as that of the land based. Maybe you need to have separate arrangement, something like that, a special arrangement, to what you call attend the maintenance or preventive maintenance or corrective maintenance or repairs, etc. So it is harder to access and replace components sometimes. Okay, it could need more frequently because highly humidity environment, and sometimes corrosion also you have to, and less lifetime of BOS components. That is okay. This is also somewhat okay. Balance of system components. BOS means balance of system components. The balance of system components working under very humid conditions. So that is why the lifetime may be reduced. Okay, less lifetime or might be affected. Submerging cables, connectors into water can cause current leakage and low insulation distance. Okay, like that. This is what sometimes biofouling on submerged connectors and cables. And other two challenges: low TRL for high wave categories, lack of FTV specific standards. Low TRL. What do you mean by TRL? Nowadays we are hearing TRL 4, TRL 5, TRL 6, TRL 8. Technology readiness level. High wave categories somewhat low technology readiness level. Especially floating platforms installed in coastal areas with membranes as floating. The technology readiness level of floating PV system for high wave categories is lower. There are 4 categories. First 3 categories are inland water areas, respectively for negligible 1 meter and 2 meter wave heights. 4th category is for the open seas, for which they can withstand waves up to 10 meters of height. compared to projects running at various places in the world, so that TRL is higher for the lower wave categories and low TRL for high wave categories. Vice versa. Right? This is another challenge. Maybe technology readiness level might be improved, or we have to improve. And specific standards, not at actually. The lack of FPV specific standards still in its nascent stages. So there are no specific standards available, like standards for ground-based PV systems. So it is not available or cannot be extended for floating solar PV plants. The land-based we cannot extend. So formulating these standards and guidelines for designers will help, okay, to ensure its components can survive environmental conditions, varying environmental conditions. I don't say that survive harsh environmental, but varying environmental conditions, dynamically changing environmental conditions while retaining quality over 20 years without causing any impact on water ecosystem and biodiversity. So that is what actually here the opportunities and challenges. I'll share a small video for 5 minutes so that we can have just I'll share a small video. I don't know whether it is
I don't know whether you believe it or not, but the world's largest solar park is the Badla Solar Park in Rajasthan, India. This image shows the area before the solar park, and this one shows it after the solar park's installation. Just imagine. I don't know whether you believe it or not, but the world's largest solar park is the Badla Solar Park in Rajasthan, India. This image shows the area before the solar park, and this one shows it after the solar park's installation. Just imagine, this small area covers nearly 14,000 acres and can generate over 2.2 gigawatts of solar power. The fact that this capacity could potentially fulfill the energy requirements of a major city like Mumbai. Friends, hope you are very excited. I also excited. In this video, we will try to understand what a solar park is exactly and how it generates power. In simple terms, a solar park is an area of land where many solar panels are installed. A single solar panel can produce a small amount of electricity, but when solar panels are connected in series, they form what is called a solar array. And it produces usable voltage. In this configuration, the positive terminal of one panel is connected to the negative terminal of the next panel, creating a chain that increases the voltage output of the array. Now, let's take a look at the structure of a single solar array. In larger solar arrays, multiple strings of solar panels are connected in parallel. The wiring from each string is then combined in a combiner box, which collects the DC electricity from all the strings and directs it toward the next stage of the system. The collected DC electricity is then fed into an inverter, which converts it into alternating current AC electricity. This conversion is necessary because most electrical appliances and the grid operate on AC power. The grid serves as an interconnected network that distributes electricity from power plants to consumers, ensuring reliable and efficient delivery of power. It facilitates the balancing of supply and demand, allowing for real-time adjustments to meet fluctuating energy needs. In this stage, high voltage or step-up transformers are used to increase the voltage for transmitting power over long distances with the help of these towers. Some solar plants utilize battery banks. It is used to store excess electricity generated during periods of sunlight for later use when sunlight is unavailable. Batteries are safely installed inside these cabinets, ensuring secure storage and operation. Battery banks are typically installed before or after the inverter stage in a solar power system. Once the electricity generated by solar panels is converted from direct current, DC, to alternating current, AC, by the inverter, any excess energy can be stored in the battery bank for later use. A solar panel consists of multiple layers, designed to protect the panel, with solar cells being the primary components. Solar cells are composed of semiconductor materials such as silicon. When sunlight penetrates the solar panel, it generates electricity, typically in the form of direct current, DC. Friends, if you want to gain the knowledge how does solar cell generate this DC current, comment below. I will back soon. Thank you. Let's grow up. Never stop learning.
Yeah, just a minute. I'll come back. So meanwhile, you can ask questions. You can type the questions so that so no screen sharing. Just now stop it. Yeah. So any questions? Meanwhile, you can make it. I'll come back with small video animation like see this one like world's largest. Of course, it's Google directly. One can also go through that. I'm sharing that one also. Yes, share that. Yeah. Hope you understand, okay, the demand, how it is, and the explanation will do. So questions are there. Sir, if possible, please share the test link in chat box. Yeah, sure, sir. Kindly.
No, sir. That is after the session. Test is the sir. That's the
Test,
participant
test last,
asking.
yeah.
Next session, sir.
Yeah, yes. So any other questions? Like
Any
say,
questions,
might not be
participants?
done. And coming to the challenges and opportunities. So if you want to publish the papers, you have to focus on challenges side. Opportunities anyway, okay, they are research literature is available, and okay, they are opportunities, so that no need to focus, no need to attend, okay, these opportunities. But if you attend the challenges and do some work, research work, so that you can publish, publishing scope will be more. Even I have seen several papers, nobody has published the
Sir,
results.
1 minute,
Yeah.
if you don't mind. Sir, Mukul Balaji, sir, raised a hand.
Yes, sir. Good
Please,
evening,
sir.
sir. Rama, sir. Hello, am I audible, sir?
This audible only, sir. Please
Yeah,
proceed.
Mukulji, yeah, yes.
Yes, sir. My question is, sir, in FPV, floating solar PV, which types of simulations are we are used in research work?
Actually, it is not that complete photos or floating solar PV plant. If it is floating solar PV plant, there is no straightaway software, okay, to publish the results of entire floating structures. But see, if you only floating structure or mooring or anchors, okay, those things, Altair software or the design softwares like CAD, okay, CAD softwares and all, you can go through that. Even ANSYS, you can work out on ANSYS to show what you call better performance of your design, anchoring design or mooring design, like that. But there is no straightaway single software for entire floating.
Okay, sir. Okay. And sir, that is more costly compared to the LPV?
Yes, more costly compared to MATLAB and open source. Sir,
Okay, sir.
Srinivasanji, were these FPV plants in India? Yes. In Andhra Pradesh, it is there. You are lucky. In Andhra Pradesh, it is there. And West Kallada, I shared already 2 plants. And largest is so far Singapore, but now China is going for biggest, very biggest, world's biggest almost 2 gigawatt.
Okay, okay. Okay, sir. Thank you, sir. Thank you.
Yeah, welcome.
That is very, very informative, sir, for us. Yeah, thank you, sir.
Yeah, yes, sir. Already I shared the handout. I think sir will share, organizer will share the.
Yes, sir. Yes, sir. After that, all the PPTs
Yes,
we will
sir.
share in the group, sir.
Thank you, Madam Manoranjitam. Yeah, thank you. So thank you, dear all participants, for your patience listening. Just whatever I gained my experience, I shared it. There's no research in this topic, but still there are some challenges in floating solar PV plant. You can work out.
Sir, Professor,
Yes, sir.
shall we move
Shall
to
we wind up this session? That means
sir, what of thanks?
what of tax?
Okay. Sir, please, sir.
Yes, sir.
Sir, நீங்க proceed பண்றீங்களா?
No, no. Rajashri ma'am,
Sir.
please.
This is a time for the vote of thanks. Now I invite our department faculty member, Mrs. Rajashri, to deliver the vote of thanks for this session. Please, ma'am, take this session.
Okay, thank you, sir. Good evening, everyone. I am Rajashri from EEE Department of Holy Mary Institute of Technology and Science. It is my privilege and honor to deliver the vote of thanks for this enlightening FDP program on challenges and opportunities in floating solar photovoltaic technologies. I would like to extend our heartfelt gratitude to our speaker, Dr. PVV Rama Rao, for their inspiring and thought-provoking sessions. Your expertise and insights have provided us with a deep understanding of challenges and opportunities in floating solar photovoltaic technologies play in shaping a sustainable future. To our participants, your active engagement have been remarkable throughout the program. Your insightful questions and discussions have truly made this FDP dynamic and meaningful. Once again, thank you all for your presence, participation, and contributions. Let us continue to work together toward a greener and more sustainable future. Thank you. Thank you, sir.
Thank you.
Okay, sir.
Welcome, madam. Thank you. I think we can have a group photo screenshot.
Yes, no,
Yes,
sir. Please, all the participants, please turn on your video. We'll take you one photo. Anyway, later we will join in the validatory function. Okay. Before that, please. Professor.
Taken.
Okay, boss. Thank you. Professor, instruction கொடுத்துடலாமா அப்ப போஸ்ட் பண்ண போறோம் அப்படின்னா
Yeah.
நீங்களே சொல்லிடுங்க.
Okay, Professor.
Yes, sir. Welcome, sir. Right, sir. See you.
Okay, thank you,
Thank
sir.
you. Thank you, Professor. Actually, we are planning for the same link for next session. That means test link.
Yes.
Anyway, thank you for the timing, Professor.
Yeah, welcome, sir.
Okay.
Right, sir. See.
Thank you very much.
I'll be back. Yeah, if you send link, I'll try to join.
Okay.
Definitely, sir. We will share, sir.
Okay. Sir, post the link. Link in chat box or a group?
Both, sir. Both.
Link is there?
உங்களுக்கு ஷேர் பண்ணிருக்கேன் ப்ரொஃபசர். ஆல்ரெடி ஷேர் பண்ணிருக்கேன். ப்ரொஃபசர் சொல்லிடுங்க எல்லாரும் இந்த 1 hourல பண்ணிட்டு திரும்ப they have to join in validatory.
Okay. This is the time for 1 minute. Oh, 1 minute. ரெண்டு ஃபார்ம் இருக்கு.
சொல்லிடுங்க ப்ரொஃபசர், போட்டலாம். சொல்லிடுங்க, ஒன்றும் பிரச்சனை இல்லை. ரெண்டுமே உங்களுக்கு திரும்ப அனுப்பிச்சுடுறோம்.
No, 1 minute. Okay, now we are going to post the test link chat box as well as in group. Just to have a look and then fill it. It will be this session will be 6:30 to 7:30. Those who won't be online means you can online. You fill it just to submit the things. You can see immediately response of results. Next session validatory function will be start 7:30. We will send the separate link. Saravanan sir, please post the.
Okay.
I am confusing.
Okay, sir. I will post.
Yeah, post both. Sorry, chat box as well as group.
In the group,
You
I
want
will
to
post.
see that you can stay, no issues. It will be online only. Shall we stop record this session?
Okay, sir.